Hello everybody, we're in section 2, chapter 2, section 3 of our textbook, talking about organizing quantitative data this time. In the last section we talked about organizing qualitative data using tables, frequency tables, using pie graphs, and using bar graphs. Well, this is actually very similar, except that we have a few differences when it comes to ways that we organize the quantitative data itself. Now let's consider this table right here. This is quantitative data, and it's listing the number of TV sets in each of 50 randomly selected households. So we see some households have ones, at least one here is 0. Some have as many as 6. Wow, well, that's a lot. But anyways, any of these represents the number of 50. Just looking at the table, it doesn't seem to really help us a whole lot. So just like our data from our last example, we need to find a way to organize this. And of course, we do exactly that, right? We would go through and we see that we go for range from 0 to 6 along our vertical axis right here in the column 1, right? This is our particular groups that we have, right? Since this is discrete data, right? The number of TVs only come in whole numbers, and in this case, in our survey, we found 0 to 6 was the normal numbers. When we counted up the frequencies, right, here they were. We said out of 50, right, we got, looks like 16. Most had 1 in their household, right? Some had 2. A lot had 3. Those were the largest numbers, right? Then the numbers went down from there. And then we got our relative frequency. So if we took 1 and divided it by 50, we would get 0.02. If we took 16 and divided it by 50, we'd get 0.32, and so on down the list. So here's our relative frequency. So what could we do with that data? Well, we could take this kind of data and we could actually just go through and organize it in a table, and we'll take a look at how we organize that in something called a histogram, which is a kind of bar chart for quantitative data. But let's talk about another one here. This is days to maturity of 40 short-term investments, right? Same kind of thing. Now, you might want to pause for a second and see if you can construct your own data table, but you see that the data right here, well, there's a lot more range to it, right? We're going from 38, it looks like, right? What's our low number here? I see 36 right here. And I see 70. That seems like a pretty high number. Here's one, 98. Wow. Well, this is quite a range of data, right? So it's not like we can arrange them single number by number. So in this case, we might need to actually find a different way of organizing this kind of data so that we can outline what its frequency does. And so what we do here is that rather than talking about days of maturity by single days, right? Somebody had 36, somebody had 38, all of those things are different. What we do is we put them in ranges. Sometimes we call that range a bin. Depends on the program you're talking about, but we can call it a bin, right? In classic statistics, we say each of these categories right here are bins for numbers, right? It's kind of like a bucket, right? A bin is a bucket. I think of a bin or a container, right? So each of these containers, 30 to 39 and 40 to 49 and 50 to 59, right? So now what we do is we go through and we start counting, and we take our tallies right here. We see that there were 3 investments that had a total of 30 to 39 days. 40 to 49, there was only 1. There were 8 that had that data from 50 to 59 days, right? 10 from 60 to 69 days, and down our list, right? So those 40 investments, right, we can see our frequency of those investments that came to fruition, that came to maturity within that day group, right? So another way of organizing is to make sure that we draw these bins or categories of numbers and then organize them into those groups. All right. Well, we can do the relative frequency thing, of course. We take each of these numbers. 3 divided by 40 gives us 0.075. 10 divided by 40 is 0.25. That's 1/4 or 25%. And so on down the list. So, so far, so good. But let's see. If we are grouping those data, the question might be, how do we come to these groups, right? I mean, how did we actually come to the group that we should have 30 to 39 and 90 to 99? Why didn't we go 35 to 39, then 40 to 45, right? What gave us this? Well, one principle that we like to have is that, first of all, we really don't like to have more than maybe 7 categories, right? You know, I would typically say on a day that you're going to come up with your own group, right? You don't want to have more than 7. Less than or equal to 7, typically, right? Sometimes as many as 10 categories. Depends on the data itself, but no more than that, right? We want to keep the number of categories that we use low, right? So that's an important thing. So we decide on those categories based on some of the following information. So this is some terms you need to know in order to come up with your own groups. First of all, there's a lower class limit. That's the smallest value that could go into a class. And there's an upper class limit, right? So this upper class limit is the largest that could go into a class. There's a class width. Now the way that we get the width of the data is to take the lower class limit of one group and subtract it from the lower class limit of the next group. Then we have something called a class mark, which is the average of the two limits of those classes. Let me show you what I mean right here. If we look at our chart again, we see that the lower class limit in this group here, we'll take the second group, is 40, and the upper class limit is 49. So when we say lower class and upper class limit, we're talking about the smallest value and the largest value that will fit into that group. On the other hand, we talk about class width. Well, the class width for the class that starts with 40, we go to the lower end of the next class limit, right? So we take lower class limit minus lower class limit of adjacent groups, and we subtract those to get our class width, and this time our class width is 10. The class mark is what would be right in the middle, and there's some kinds of procedures for getting averages, which we'll talk about eventually, that require us to find a middle part of each one of these groups, and in this case we call that our class mark. Our class mark is 40 plus 50, that should be a 50 right there, that didn't come out very well, times 1/2, well, the class mark for this group is 45. So there we go. Okay, so this is the way that this should work here. Another way to group, sometimes if we have, this is called cut point grouping. We would use cut point grouping if we had data that came in continuous groups, right? So in that case, then we go to lower, what we call cut points, right? A lower class cut point and an upper class cut point. We say the lower class cut point, just like our lower class limit, is the smallest value that can go into that class. But if we had continuous data, right, the largest value that could go into the next higher class, we call that the upper class cut point, and that's equivalent to the lower cut point of the next higher class. What we say is that we're looking for the next lower number that could fit into that group. The class width is the difference between the cut points of a class, right? So this upper class limit, by the way, is kind of like saying that 50 and 40, right, in our last group. Class width right here, difference between the cut points, and then the class midpoint is the average of the two cut points of a class. We'll come to an example where we show this in Excel, and I'll talk about those. But where do we use these? Well, if it's a single point grouping like we did with our TVs, we use discrete data. And there's only a small distinct number of values, and we don't have to worry about what groups pieces of data go into. Limit grouping, we use that when the data expresses whole numbers and there are too many distinct values to employ a single value grouping. That was the case with our days to maturity. Cut point grouping, the last one I talked about, is when the data are continuous and are used with decimals. So what kind of graph do we use? We use a bar graph for our continuous or discrete data, but for numerical data we use something called a histogram. A histogram displays the classes of the quantitative data on a horizontal axis and the frequencies on the vertical axis. So the frequency that we're talking about right here could be the relative frequency, or it could be the frequency itself that counts within each of those groups, and the bars should be positioned so that they do touch each other in this case, right? The reason for that is if our numerical data, right, we count numerically and there are no gaps between our numbers, we want to make sure that we're not missing things. Unlike our qualitative variables, which have no touching points, right? Numbers do. So for a single value grouping, we use distinct values or observations and label the bars and just make basically a bar graph with the bars touching. For limit grouping or cut point grouping, the lower class limits and the lower class limits form the marks that we put along our horizontal axis. So let's see what that looks like. If we want to construct a histogram, we're going to obtain the frequency. We're going to draw, this is a lot like our bar graph, right? Draw the horizontal axis, place the bars in the vertical axis to display our relative frequencies or frequencies. For each class, get a vertical bar whose height is equal to the frequency, and then label those bars. We have that TV data, you'll recall, in the television sets per household. And when we counted the frequencies, remember, we said what the number of households that had one TV, there were 16 of those, right? So we see that the height of the bar right here, our histogram, is 16. And you'll notice that with each of these values along the horizontal axis right here, we're just covering the whole numbers of TVs, right? So these are single value groupings, and the heights of their correspond to their frequencies. And you'll notice that the heights of the bars do not change if we call that a relative frequency. The only difference is that we're displaying percentages or decimals rather than whole number frequencies. When we talked about our days to maturity of our investments, notice that we used groupings, and you'll note how it works along the horizontal axis here. That's a little different. Days to maturity, we started at 30 to 40, right? 30 to 39, and then 40 to 50, 49, and then 50 to 60, and so on down the list. These categories now could include all the values that were between 30 and 40, and we put them on this frequency. Right, so if we count the frequencies along the vertical axis right here, this is what it looks like. This is our frequency diagram for short-term investments, and here's our relative frequency for short-term investments. And notice that the vertical axis is marked in those percentages. If we were to talk about continuous data, like for example weights of 18 to 24-year-old males, we could see, like for example, we could categorize them in 120 to 140 ranges, right? The cut points here are 120 and 140 and 160, so we're actually plotting those cut points in our graphing. And just like in our relative frequency graphing and our frequency graphing, right, our bars are relative to the heights. Okay. There's a couple of other methods that we can use depending on the method. For example, we have something called a dot plot. A dot plot is where we place dots above each observation at an appropriate place on the horizontal axis, and dots are stacked to represent the number of pieces of data within that thing. So if we go through here, let's say price paid in dollars for 16 DVD players. Here's their prices, right? We could go through and say, oh, let's go above our number line. Above this number line, we see that there was one that was about 199. 199 was a single value, right? There were 3 of those. Looks like there was one. Oh, 197. Here it is. Here's 197, right? We see that that was in there. Each dot represents a height, so it's kind of like having a bar chart. Now, dot plots, they're just sort of quick ways of getting values over a number line to compare frequencies, and they're used rarely, but sometimes we do use them. Another kind of plot that we use, and this is usually a quick one-off if you're doing statistics by hand and you want to organize data and you've got a small number of data plots to look at, a stem and leaf plot is the one to use, and I'll show you one. But I'll tell you that in teaching, I often use stem and leaf diagrams, especially if I want to look at how frequently a grade within a group appears. So if I have a large class of 50 students and I gave them a test, I might go through and actually use a stem and leaf plot to get a frequency diagram of how well they did. So the way you think of each observation is a stem consisting of the rightmost digit and a leaf, which is the leftmost digit. Sorry. Left and right. Actually, this should be leftmost. I don't know why that says rightmost. I think that's a typo. Write the stems from smallest to largest in a vertical column in the rule. Write each leaf to the right and arrange those leaves in ascending order. So here's our example. Let's say that we have days to maturity of our 40 short-term investments again, right? Only this time, rather than doing groups where we have cut points or groups of 30 to 39, 40 to 49, and so on, what we're going to do is we're just going to say, let the first digit in each number represent the stem, and the second digit in each number represent the leaf. So if I were to draw this out and I picked my number 56, right, which is in my investment group right here, I see 56, right? What I'm saying is that my stem is 50 and my leaf is the 6. Right, so this is one of your handout questions. Let's see if we can arrange it. What we're going to do is that we're going to just count these numbers one by one and just start filling it in. So for example, we might see that the first number in this slide for 30s is 38, right? Here's 38, right? And as I go down my list, I try to find any other 30s that I can see right here. Do I see any other 30s? There's 38 right there. I'm looking closely. Do I see any other 30s? No. Then I go to the next column. I see a 7 for the 40s, right? 47, right? And I'm just going to go down the list, and I'm just going to one by one try and get rid of each of these numbers. Oh, wait a minute. I was wrong. I found a 39 right here. So I'm going to put a 9 right here. Used up that number. And I'm just going to go one by one and just start filling in the leaves for each of these. Now, you'll notice that when I do it right here, none of these leaves are really in order. Right? Do we have any others that I missed? 38, 39, 68, 53, 47, right? Oh, I missed 36. There's 36, right? So if I want to do this, right, and I arrange it in ascending orders, eventually what's going to happen is that for that first number, I'm going to rearrange that 6, 8, and 9. There's only 1 4, and there's a 7 right there, and that's what the first couple leaves. So take a minute right here, pause your video, check that out, and then I'll show you my solution. Okay, you ready? Here it is. This is what my stem and leaf chart looks like. We asked that, how do we construct it? Well, there it is, right? We're just using the numbers themselves as the bars. And as we go through it, if we went left to right and we just started counting, let's say with the 6s, we see 2, 4, 7, 3, etc. But then we rearrange them in ascending order. Notice how we put these numbers here in ascending order. We want to do that because this is also, in addition to being a way of visualizing the data like a bar chart, we're organizing the data in order. And that is actually a very important thing for us to be able to do. All right, one last example right here. Right here's another example of stem and leaf charts. If we have 2-digit numbers, right, sometimes we can use the 2 leading digits as a leaf. Now, when we do that, right, we get a smaller number of categories, like in this case, so we can actually divide up the leaves and say, well, okay, if it's from 0 to 5 or 0 to 4, we're going to put it right here. If it's from 5 to 9, we're going to put it here. Right, so you notice that we're dividing it up. And sometimes you can granulate, divide up your levels to help you see that data a little bit more clearly. Okay, well that's it for this section. We'll get into some classifications of distributions in a minute, and then talk about dealing with Excel graphing, and I'll show you some examples of those later. Good luck.